Centripetal force is the force required to keep an object in circular motion. So in the case of an object in orbit, the centripetal force is the force acting towards the centre of that orbit. It's the only force acting on objects in orbit, and it's equal to the mass of the object in orbit times the velocity of the object squared divided by the radius. If we look carefully at this formula, it's in the same format as F equals m times a, where the a is equivalent to the velocity squared divided by the radius of that orbit. So it's very, very simple. We can let gravity be equivalent to this. Or d squared. So we can then, this is the object in orbit, and we can let one equal the other. So m2v squared on r equals g m1 m2 d squared. You can see there we get a formula for orbital velocity, which can be used to find the orbital velocity of an object. There's other cases where you can do that. Instead of this, we have the orbital velocity is the distance around a circle, which is 2 pi r, divided by the time it takes, or the period. So we have different formulas we can use for orbital velocity. We can also use this formula for orbital velocity in another formula that's commonly used as part of Kepler's laws. Where r cubed, the radius cubed on t squared, equals a constant, which is the central mass. So this constant here would be equal to, if we used the sun or the orbit of the Earth, so the radius of the Earth's orbit divided by the period of the Earth's orbit equals this constant value, and this would be the sun, the central mass. You have to be careful because this mass here is the orbiting mass. So you've got to be careful you don't use the wrong mass for those equations. But that would also equal the radius of Saturn divided by the period squared of Saturn. And also equal the radius cubed of Mars divided by the period squared of Mars. So they're always, because they're going around the same object, they're constant. And we can use this formula, and we can use our orbital velocity. And the orbital velocity was v equals 2 pi r on t. Well, if we rearrange that, multiply both sides by t, we get this formula, 2 pi r equals orbital velocity times t. And we can divide both sides by v then. We get orbital velocity equals 2 pi r on v, because they both cancel. So this t value we can then put into Kepler's law. And that will look like 2 pi r on v. So we're putting this value of t into this formula, squared, and that equals this constant value. This is the gravitational constant, mass of the central body, and 4 pi squared, sorry. If you solve for this then, for the whole thing, v, you'll end up with a similar formula to the one we had before. In fact, identical formula. V equals square root of g m on r, and you can see that up here. Instead of r, we use d for the distance, the radius of the circle. But that, once again, we have the orbital velocity.